Hello, everyone. Can you hear me?
Yes.
All right. Okay, hold on a second. All right, let's see. We have 21 participants. Yeah, I'm expecting a few more. So I imagine everybody had access to the Canvas. That was where you found the Zoom link, right? Let me share my screen. Okay, that's great. Can everybody see my screen?
Yeah.
Yep.
All right. Everybody, just one more minute. All right. Okay, welcome everybody. My name is Jose Anunciado, and I believe we're all here for web development. So we're going to be learning for the next 14, 15 weeks. We're going to be together learning on how to create web applications using web technologies. Several web technologies are going to be working together and creating a technology stack that are going to collaborate together to build an entire web application. Right. The overall arching architecture will be that we'll have a front-end application, which will be built on React.js. We'll have a middle tier server implemented in Node.js, right, implementing a RESTful web API, and then connected to a non-relational database, MongoDB, for permanent storage. So that's the overall arching architecture and technology stack that we're going to be using throughout the semester. And we're going to be learning each one of those technologies all throughout. The first half of the semester will focus mostly on the front end part, on all the how to create user interfaces using HTML, CSS, make responsive applications so that you can use them equally well in small screens such as phones or tablets, or in full desktop application, desktop monitors in the desktop application, and then using JavaScript to create dynamic content, React.js for functional components, reusable functional components, and Redux for maintaining state on the application. So that's going to be the first half of the semester. The second half of the semester, we're going to be focusing more on the back end, creating our own HTTP server to host data that we can retrieve and write to a database, and creating login, maintaining session on the server, being able to register, log in, create a profile, and maintain, keep track of user interaction so that we can scale this not only with one user, but multiple, dozens, hundreds, thousands of users. So that's going to be the overall architecture of what we're building and how we're going to be building it throughout the course. Okay. So you should all have obviously you should all have access to Canvas, and from where you should be able to access the syllabus, as well access the Piazza. We're going to be using that Piazza for asking questions, answering. You can follow up there. Your other students might answer, or the TAs or myself. There will be a final project that you're all going to be working together. You're going to create teams of up to 5 team members, and you're going to collaborate to build an application of your choice. There is a text that is required, some questions in the exam, and also gives a lot of background information, some history, so how we got here. That complements very well the fast pace of this course. We do have 3 office hours, 1 for each section. There are 3 sections that we are using more or less the same content, and there's one undergrad course that is running in person in the Boston campus on Mondays and Thursdays. And then there's this section, which is entirely online and asynchronous, which is all every Monday from 6 to 9. And then there's another section which is also on campus that runs on Thursdays from 6 to 9. So anyway, so each section has its own office hours. With myself, plus the TAs are going to be publishing their own office hours soon. They're going to present themselves and say hi and suggest what office hours they can have throughout the week. And they're going to be publishing their office hours here as well. Now, even though each section has its own office hour, you're welcome to come to all the office hours, right? So even though this is the office hours dedicated for the CS 4550, the undergrads tomorrow, you're welcome to come. But I do have to give priority to the undergrads at that particular scheduled time, right? So I'll keep asking, are folks from CS 4550 here? I'd like to help them first, and if there's time at the end, usually there is, I'll have any graduate students that might be there. Same thing I've told the other sections. Yours is for this section is on Wednesdays, and I've told all the other sections if they want to come, they can, but I need to give priority to you folks. Same thing, the one on Friday. So the TAs are going to offer additional office hours. I think there's like 14 TAs, right? So, and each one is going to have at least 2 hours. So there should be plenty of time for you to speak to someone who be able to answer your queries. All the assignments will be submitted using GitHub. And is there a way for you to show a show of hands how folks feel about GitHub? I imagine everybody feels comfortable on using GitHub, perhaps in other courses as well. But yeah, so all assignments will be submitted at a particular GitHub repository, and each assignment will have a dedicated branch off of the same repository. So, for instance, assignment 1 will be branch A1, and then assignment 2 will be branch A2, assignment 3 will be branch A3, and so on and so forth, right? So that will allow the TAs to grade the previous assignment without you worrying on overwriting any work that you might have done before. Same thing, we're going to be deploying all our work on a front-end public server hosted at Netlify. And Netlify allows you to map each GitHub branch to a separate instance of the web application hosted on Netlify. That also will enable TAs to grade assignments from, say, last week, while you still are working on the next assignment, which will deploy in a separate URL. So that's great. It'll allow us to work as staggered. Okay. So okay. Any questions so far? I'm sorry, I'm talking a little bit too fast. Please feel free to stop me, and if you have a question, we can go over it.
Excuse me, sir.
Yes.
Do you think it's possible? As I'm from like San Francisco, so all your office hour will be like 5 to 6 a.m. during the morning.
Oh, okay.
So do you think you can like reschedule one of your office hours so that if in case?
Yeah. Let me do that. Yes. Let me.
Sure.
Perhaps maybe 11 might make more sense for some folks on the West
Sure.
Coast.
Thank you.
Yeah. Let me do that. Sure. Let's see. Anything else? Well, that's the same. Sure, partner. Is identify the standard, or we can use GitHub pages and provide link. So we're going to be hosting a React.js applications running JavaScript, that so we need to deploy deploy things that are going to be compiled and linked and it needs to be hosted in an Node.js server. I'm not quite sure that GitHub Pages allows you to provide the compile and transpile React.js components and JSX into low-level JavaScript. We could take a look at it. If that does work and you get it to work, please let me know. We can discuss that offline.
It does work, Professor.
Oh, okay, then sure. Yeah, that might be one option. Sure. Let's see. What else? Okay, let's take a look at the syllabus. Why is it still coming? Right. So the goal of this course is to learn about several web-related technologies that work together, can collaborate. Implementing a technology stack, right? That implement a front end, a middle tier, and a database. Okay. There will be about 10 assignments that are going to be building on each other. So I'm going to be asking you to really be on top of the assignments and make an effort, not to fall behind. There's 10 assignments. It's 14 weeks. So there's going to be a couple weeks where we're not going to be having assignments, but most every week there's going to be an assignment, right? Starting today. This first assignment and assignment 6 are the I guess some of the more challenging ones. So we'll be giving you a couple weeks to get started on those. This first one is the first assignment is mostly just setting up the environment, and that tends to be fairly painful. So I would hope that most the students, perhaps 80–90% of students will be able to do this very quickly. But there'll be 10 to 20% of the students who will be struggling, and we need time to help them out and get them up to speed with the environments, right? Because of different operating systems, different versions of libraries, or things that you might have installed already that are incompatible with what we're installing. So setting up the environment is one of the more painful parts of getting started, right? Also, the next more challenging assignment is going to be the Redux, setting up and maintaining state at the application level on the React side. And so that too, we're going to give you a couple weeks on that. So that's going to be during the spring break. You'll have some time to work through that and really get up to speed with that part. But all other assignments they're all 1 week, and so they're all very hands-on, lots of coding. So please make an effort to stay on target. Ask for help if you get stuck. If you think you're lingering too much on something, please come to my office hours. The TAs are going to have plenty of office hours. Ask for help. All right. Okay, so there's chat. Is it up to 4 members or 5 members? So yeah, this semester we're going to allow folks to be up to 5 members. So for the assignment, in the assignment, we're going to be building a we're going to handhold you through implementing a particular web application, right? And it's very rigorous. We tell you exactly which languages to use, which technologies to use, right? And it's very specific on what you need to do in a particular order, and you have to stay within those rails, right? So for the front end, we're going to be using React.js, HTML and CSS, obviously, Redux for the front end. For the middle tier, we're going to be using Node.js, running an Express JavaScript server, and for the database, we're going to be using a non-relational MongoDB database. Now, for the projects, for the team project, which is at the end of the semester, you are welcome to use and explore other technology stacks, right? So if you prefer to use a relational database such as MySQL, Postgre, or something like that, you're welcome to use that instead. If you prefer to explore some other server technologies, maybe you'd like to play around with C# or Java, Tomcat, or Python, or Firebase, right? You're welcome to explore other alternatives for the middle tier. And for the front end as well, you're welcome to explore things such as Vue.js or Angular or some other front end framework. Okay, so it's the team project is fairly open ended on what is that you're going to be building. You can choose the topic as long as you keep it in PG-13. You're welcome to do whatever you want to do, right? As long as the team agrees on what is that you're building. There are requirements of particular things or functionality that you need to provide, that all projects need to fulfill certain minimum requirements. Like everybody has to support being able to register, log in, having a profile page, interacting with some kind of third-party API. There has to be some kind of social network capability of folks interacting with one another somehow, either following each other or sending each other messages or some kind of way. So there's some specific functionality that all projects need to support. But the topic, it's up to you, and what the technology stack looks like is also up to you, right? But for the assignment is very well defined. You're asked to follow instructions very closely. So we're going to be meeting on Mondays from 6 to 9:30 on Zoom, obviously. And so here are the meeting times. So these are for all the sections, right? So this morning this morning I met with the CS 4550 folks, and now I'm meeting with you. So these are these are Zoom links for those meetings, right? If you missed today's lecture, you can either see it recorded for all lectures are recorded, so you're welcome to take a look at that. But you can also, if you want more pain, you're welcome to catch another episode either in the mornings at 11:45 on Mondays and Thursdays, or on Thursdays 6 to 9 as well. Okay, if you really want to hear the lecture again live, you're welcome to join in using these links. Okay, so the instruction team. So this is me, and these are my office hours. Again, Tuesdays from 8 to 9. That's for CS 4550. Wednesdays for you, and Wednesdays and Friday. So I'm gonna revisit this and add a couple of office hours later in the day, so that's more convenient for the West Coast folks. The TAs are going to add their own office hours. They will be posting that on Piazza perhaps later today or tomorrow. and letting you know. I've asked them to provide some coverage of office hours in the weekends, because all assignments and projects and everything is usually due on Sunday evenings at midnight, right? So every Sunday at midnight there's an assignment due, or the project is also due on at midnight on Sunday, and so I'm sure you'll need a lot of support over the weekend, Saturday, all day Saturday, perhaps Sunday in the morning. And usually I'm guessing after having submitted on Sunday, on Monday, you might want to decompress and kind of forget about web dev for a day or so. So there might be a little less coverage in office hours on Monday, and then a little more as we progress towards the end of the week. Okay. Let's see. So here's the agenda. So there's a tentative agenda that we're going to be trying to follow, although depending on how we're doing, if we're speeding up or slowing down, we might change this just a little bit. So today is mostly just introduction and setting up in the environment and introducing you to the first assignment, A1, which is just setting up the environment. Now this is due on the 22nd, so you have plenty of time to work on this. Again, it's I imagine that 80% of students will be able to breeze through this, but there might be some folks that might suffer through setting up an environment. Again, depends if you've installed databases before or not, if you've installed Node.js in a previous course or not, and if we have any conflicts with other technology stack that you might have already in your on your machine. So this is a little later. So after that, though, all the assignments are 1 week after that, right? So assignment 2 is 1 week later, then assignment 3 is a week after that, and so on and so forth. Okay. So we're going to focus on setting up the environment. So next week on Monday, so my understanding is that Monday is a holiday. And so the undergrads are not having a lecture, but I'm planning on having a lecture next Monday. You're welcome. If I'm not quite sure what the policy for holidays like that are, if you don't want to come, that's fine. It'll be just me. And you can catch the episode recorded the next day if you prefer to do that. If it's said you want to come, I'll be here next Monday. I'll be talking about HTML next week and presenting the second assignment, which is all about HTML. And that's going to be due at the end of this month. All right. And then on week number 3, we're going to so HTML is a programming language that describes the content of web pages. So for instance, this is a web page here, and it describes the fact that we want this title over here, that we want these images, right, that we want the button over here, that we want a drop down over here, right, and all those kinds of things. So it describes the structure of the screen, right, that there's some scrolling here, right, things like that. So CSS is another language. It's a cascading style sheet language that describes the look and feel of the web page. It describes that what fonts to use, with what background, what foreground colors, if it's underlined, the colors of these borders, that this button has to be blue, and it has maybe a couple of rounded corners, that this is kind of like rounded like a pill, things like that, right? And that makes things look pretty, right? Just paints and sets the look and feel of the screen. Okay, so that's CSS. We're going to spend a week there. Now, HTML, it's not that we're going to only be looking at HTML just that 1 week, right? So we're going to introduce HTML at week 2, but then we're going to be talking about HTML all the way throughout the entire semester, right? So, and just, getting into more and more practical uses of HTML. So for CSS, again, as well, we're gonna introduce the concepts, the syntax, right? How it works. We'll do some really very simple examples on how to style things. But we'll quickly learn that it's really hard to make things look pretty with just plain all CSS, right? Especially if if we're not artistically inclined, right? And we don't have an eye for the artsy part, right? So for us developers, it might be fairly challenging to make things look pretty, even though, yeah, sure, CSS has everything you would need, right? It's really you need to practice it a lot over quite a bit of time to really master it and look things pretty. So instead, we're going to, on week number 4, we're going to be using a commercial grade style sheet library, all right, which is called Bootstrap. I mean, there's tons of style sheet libraries, and we're going to be using Bootstrap for our assignments. Bootstrap and Font Awesome, those two. Okay. You're welcome to explore other libraries for your project at the end of the semester. There's like Tailwind. There's quite a few other libraries, alternative libraries, materials, and so you're welcome to explore those for the project, but not for the assignment. For the assignment, please stick to Bootstrap. Right. So we're going to stand. So this Bootstrap is going to be it's a commercial library, CSS library that maintained by some professionals that by just applying a few properties and classes and styles, you can make your content look very, very pretty and very professional. Okay. Notice that that week number 4 is when we're going to have our first quiz. Right, and then after that, it's mostly one quiz every week, right, all the way through the first exam, right? So yeah, let's keep talking. So up until now, the first 4 weeks, the content that we're going to be building is going to be static content, right? Think like a brochure or a magazine article, right? That doesn't change over time, right? It's always static, always the same content. It doesn't matter if users interact. There's no way for users to interact with it. So it's going to be static. It is going to be responsive though, meaning as you resize the screen, the content will change, right? So that it's readable in small screens like a cell phone or a tablet or even a desktop. So it's responsive to the width of the screen, right? But not interactive in that as you click or type or drag, right, the content's not going to do anything. So for that, we're going to be needing JavaScript, right? So week 5 we'll introduce JavaScript, which is considered to be the programming language of the web. It's the it allows you to write code that can execute on the browser, right? So this browser behind the scenes is executing JavaScript, right? And it can programmatically control the browser, right? It can listen for me moving the mouse, or clicking the mouse, right, or clicking a button. It can consume events that the user generates, and then respond to it by highlighting or copying or dragging or adding content, removing content, animations, whatever you want, right? So JavaScript. So we'll also spend a little bit on jQuery. jQuery is a library that kind of creates a thin veneer on top of the browsers. Browsers in the late 90s, early 2000s, there was kind of like a all-out war amongst the large corporations. The Netscape. Google's and Apple and IBM and Microsoft, right? They got into this huge fight to take control of who was going to control the content on the web, right? And that caused the competition between these guys kind of fragmented the browsers. There were certain features that were available on one browser, but not in other browsers, right? And one way that they distinguish amongst themselves, right, to compete was by dividing the JavaScript language, right? Promoting certain features that you can control through JavaScript only on certain browsers, but not other browsers, right? One of the worst offenders of this was the Internet Explorer. Trying to lure developers towards their platform, towards Internet Explorer. Yeah, they were kind of like, hey, here's a better JavaScript, use our language, our version, and you'll be able to implement better applications, better content, and blah blah blah. Anyway, so that was a mess. Just for us developers, it was a mess. Now, right, we had to write code, for the different versions of the browsers, for the different vendors. It was just a nightmare. So what jQuery did is that they kind of took the approach of Java. Code once, run anywhere. Right, that was the mantra by the Java folks. So what they did is they created a small virtual browser that hid all the details of the specific browsers, right? So that you can now code to the jQuery API without having to worry about whether I was running on IE or Chrome or Mozilla or anything, right? I just coded to jQuery. jQuery did all the translations for me, right? Anyway, so we'll spend some time doing that. And we'll be manipulating interacting with the browser directly. How to add content, remove content dynamically, how to change colors dynamically, how to add, do dynamic content generation using JavaScript and jQuery. Now this is going to be very low level, right? Talking to the guts of the browser, and so even though jQuery is a thin veneer, right? On top of that underlying guts of the browser, we're going to abandon that for a better approach, which is going to be React.js. So React.js is a library that is going to allow us, it introduces a kind of a very thick layer of abstraction so that you don't have to deal with some low-level stuff. You can think about web applications as component technology, right? That it's just functions that compute content, right? And make it very, very easy to generate dynamic content from the browser. So we'll spend some time on that. We'll implement lots of components and navigation, and also maintaining state within that application. Now, this assignment 7, is a fairly a challenging assignment, and that's why you're going to get 2 weeks for that, right? So this is going to give you a couple more weeks to work on this, and it's where we're going to be learning on how is that we're going to be maintaining state in the front end web application, right? Just like any application, you need to maintain state, right? As the user interacts with the web app, with an application, it generates a stream of events that then the application, as you type, as you move your mouse, as you click, okay, the stream of events needs to be consumed by your web application, by your application, any application, and which changes the state of your application. Say you're implementing an ATM, which you need to either withdraw or deposit, right? Those events cause the application to change state, which is perhaps maybe the balance of your account, right? Whether it goes up or down depending on whether you withdraw, you transfer, or you deposit, or if you transfer from one account to the other, well, it needs to, the balance needs to go down on one account, it needs to go up on the other account. So, how do you maintain that state? So it's a fairly complex and non-trivial challenge, right? So we're going to be spending some time explaining that. We're going to be using Redux as a library to maintain state. It is, one of the more powerful and complete libraries for maintaining application state. It's fairly, more or less the de facto standard in industry. It has a very steep learning curve. Okay, so I'm already asking you for your patience over Redux. Okay, we're gonna be looking at really simple examples, working through those, and until we get it right, and hopefully you'll say, "Aha, I got it!" Right? So yeah, so we'll spend some time. Also, the assignment, we'll give you a couple more. We'll give you a week an additional week to complete. So after that, we'll have our first exam. We will do a review of the exam, and then we'll have the exam. Right? I'm not quite sure how I'm going to do this. I don't know if we do the review the week before, or since the exam only is you only really need half the meeting, so you only need 100 minutes, right? So what we could do is do an exam review the week before, do a little bit of review right before the exam, if you have any last minute questions, and then have the exam right there, right? Now the exam is going to be just like the quizzes. They're going to be they're all on Canvas, and they're all self-grading, so you'll have your grade right away. And usually I'll post a follow-up Piazza post so that you can post any feedback for the quizzes if you found a typo or whatnot. So the first exam, that's going to be the 8th week. I don't know what that is. I think it's like February 27th or something like that. I think it's a calendar. February 27th. Yep. So this, I guess I should put here February 27th. Okay. All right. Anyway, so the exam will be cumulative, right? So they'll have some HTML questions, some CSS questions, some JavaScript questions, some React questions, right? So a little bit of everything. But again, it will be online on Canvas. After that, we'll have the spring break. And once you come back from the spring break, we will spend more time on the server side, right? We'll create an HTTP node server using the client server architecture and implementing RESTful APIs, right? So after that, the week after that, we'll talk about databases, how to store content permanently in a non-relational database, MongoDB. And finally, the last week of material of lectures will be state management on the server, right? So first we'll do state management on the client, on the browser, right, on the user interface. But we're going to have the state management also on the server. So this is going to allow us to folks create a session, right, so that we can establish a conversation with them, right, and be able for them to identify themselves, register with us, log in, have a profile, right, and as they interact with us, we know who they are, right, because they've identified themselves, right, and we can keep a conversation with them, so that not just with one person, but with any number of folks, right? Maybe a dozen, hundreds, thousands of users simultaneously communicating with the same web application, each one with its own conversation, right? So I have a shopping cart, you have a shopping cart, and they don't, and they're separate, right, from each other. So we'll talk about that. So after that, those are the last 3 assignments. The last assignment is how to log in. So after that, from starting week 13, it's all about the project, right? So these 3 weeks are entirely dedicated to the project, and then the last week, week 16, the last day of class, we'll have our second exam. Okay, which is when is that? That's on the 20. Let's see. That's so the project is due April 23rd, right? Project is due April 23rd. I believe classes ends around here. So yes, this Monday the 24th, right after the project is due, we will have our second exam. I believe that's the last day that we meet on the 24th. That is going to, although, is it? I don't remember because undergrads have a different end date than graduate students. I think that is the last day that we meet, and that day will be when we have the second exam. Right, the second exam is the last day of classes. The last day that we meet, we'll have the exam there. So meanwhile, so those 3 weeks is about project. Okay, I will be creating my own project as well. And so you can follow along and see what I do to get started on the project, and we'll go through all the requirements, and I'll give you examples of how to fulfill those requirements. And we will go over this quite a bit, much before this, right? Also, I do encourage you to get started on the project much before the 13th week, right? I would say that after you've done HTML and CSS, maybe. I think you're ready to get started on the project. So you can get started right away, in the way back here, right? By the third week, you can get started on the project, at least finding, who your teammates are, what is it you will work on, right? What topic you want to work on, and deciding on the stack. So I would encourage you to get started right now, right? Looking for teammates, and all that, right? Doing some of the groundwork, and knowing HTML and CSS, you get started on implementing some prototype of what the web pages are going to look like. How you're going to navigate between the different pages. If you're going to have any forms that you're going to be asking for information from the users. By next week, you should be able to start on that already, right? So I strongly encourage you to get started as soon as possible. So don't wait to week 13. Right, I'm going to get started on using all these technologies and all these skills, right, to illustrate, right, what how I would go about implementing a project, and we can work together. I'm going to be building a movie application, right, where you can search for movies and TV series, right. It'll pull down posters for movies. And you can like a movie, or you can rate a movie. You can create like a review of that movie. You can follow users and see what movies they have reviewed, right? And you can follow them. They can follow you. You can visit their profile. They can visit your profile, and see the content that you've generated, from one or the other. You can log in, obviously, and participate and have kind of like a small social network around the topic of movies or TV series. You can choose other things, right? You're welcome to choose any topic. If it's food or sports, right? Some folks might implement a sports website where you can search all the upcoming sports events that are happening. On Sunday night football. You can take a look at the scores from last couple of games, right? And you can maybe look at statistics, all sorts of pictures from about your favorite sports. People can maybe create, they can create their predictions on who's going to win. Right? They can follow each other. They can send messages. They can join fans and whatnot. Or you could have maybe a food project, right, where you can search for recipes, right, and maybe you can look at a whole bunch of pictures or the different steps and the different ingredients, and maybe you can hook it up to the FDA, and find out what the different calories are for the different ingredients, right? Or if you're looking for non-gluten, or gluten-free recipes, right? You can filter out all sorts of things, or you can search by ingredients. If I have this ingredients, what kind of things I can make? I don't know, whatever, right? You're welcome to choose the project and topic that you want to work on. Okay. So anyway, so I will be doing that for about 2.5 weeks. And on week 15, right, we will have our review for exam number 2. And then the following Monday, we will have our last class and we will have the exam. Okay. Now that week also, that week also is the project grading week. And what we mean by that is that that last week, you will demo, your team will demo your project to the TA, okay, for about an hour at most. And what the TAs are going to do is that you're going to demonstrate all the different requirements, right, that were required, right? And they're just going to go through a list, and this list is already available to you. Maybe maintenance, project requirements, thought I made it available. Maybe not. Project requirements. Okay, maybe not. I'll make it available, but basically it's a form that you fill out, and that form will have it'll be like a project checklist, right? Where you are going to be listing who your TA was. Okay, there's 14 TAs. The name of the group, who the participants are, right? What sections each participant is in. If there's 5 team members, so all the 5 names, right? And what section you're in. And then you're going to go through the different requirements. Does the home screen, is it mapped to /home? Yes or no, right? And there'll be a grading here. 5 is perfect. Yes, meets the requirements, sort of, maybe, or not at all. It displays generic content. When you log in, when you are not logged in, does it specify display something specific? If you log in, like, hello, welcome back, David, blah blah blah, whatever, right? It must be clear what it does, right? It must look pretty and polished. Is there a profile screen if I log in, right? Does it allow me to modify my information, my email, my address, my phone number? Does it allow me to change things? Does it can folks come and visit my profile page, right? Even if they're not logged in, they should be able to come and view my profile page. And depending on whether folks are logged in or not, or who they are, they might be able to see certain things or not, right? And so, for instance, if it's you visiting your profile, you should be able to see everything, right? Even your private information and whatnot. But if it's somebody else visiting your profile, they should not be able to see private information. So anyway, so this is a list, and then you for yourself, and to make sure that that you've met all the requirements, all the criteria. And then the TA is going to just go over it with you. Is going to ask you, please demonstrate, right? That even if you're not logged in, you should still have access to the website, to the different pages. So I'll ask you, demonstrate for me that you can do that, right? Anyway, so they'll give you a grade that last week. It's all on remote, right? They'll be posting time slots for you to choose a particular date to do your demo, and then you'll just demo for that day, right? Grades are due the week after that on Monday, May 1st. All right, so there's 10 assignments. Those are going to take care of 40% of the grade, right? There'll be about 7 quizzes, maybe 6, 7 quizzes, 6 quizzes. 6, 7 quizzes, and that's going to be 10% of your grade. The project, it'll be 30% of your grade, and then 2 exams, 10% each. Okay. Let's see. So the assignments, you are required to work on your own, right? This is you demonstrating certain skills that you acquire over multiple assignments, right? And the assignments are going to be very explicit on what they ask you to do. The assignments will have 3 parts. The first part will typically be kind of like a lab where you are acquiring some generic skills. Okay. Then the second part will ask you to apply those skills to build an application that we're going to be building throughout the semester, right? Over 10 different assignments. We're going to be building on each other. We're going to be building this application. And then the last part is a section that is specific to graduate students, only to graduate students, right? Where we explore just a few other more advanced topics, right? That only graduate students are required to implement, not undergrads, right? Undergrads are using the same documents, but they're not required to do that. They can if they want, if they want to explore a few things, but they won't get credit for it. Only graduate students are required to do that. For the project, you're going to be working together with other team members, and so for the assignments, the grades that you get is for what you do for each individual assignment. For the project, it's what the overall team gets, right? And then everybody gets the same grade, right? Regardless of who might have worked more than others. Okay. I really don't want to get into any drama at the end of the semester that we find out that so and so kind of slacked and didn't do anything. And some folks might be concerned that, oh my goodness, I don't know how my grade is gonna be impacted because I did everything. I couldn't get it. I couldn't get folks to help me. Blah blah blah. I don't know. So that drama, I really don't want to know about. Only if it's like really early on that we could catch this really early on and we can do something about it. I'll help you through it. Maybe we can isolate that individual and that person just works alone or something. I don't know. But otherwise, right? I mean, I don't want to hear that week 13 that hey, I've been doing everything. Alice hasn't been doing anything. David's he's really hard to work with. Bob is kind of MIA. I can't find him. That's too late, right? That's way too late in the semester for me to really do anything, right? And it's unfair, to kick out somebody way too late. So make sure that when you build these teams, that you are creating teams with folks that you trust, and that they're going to be committed, right? And they're going to be pulling their own weight. Okay. And please, yeah, let's avoid that drama. And let's see. Also, another thing is that we used to throttle the complexity of the project depending on the number of students or teammate members in the team, and that has proved to be extremely hard to grade consistently and fairly. So this time around, we're just not going to do that, right? We don't care if the team has 5 students in it or just 1 student in it, right? It's the same requirements for everybody. And you might think, oh well, people with 5 students are going to be able to do more than person with just 1 person, and that's actually not true. Large teams are actually really hard to manage. I would discourage you from having a 5-person team. It's folks, it's really hard to coordinate, and people are like overriding over each other's toes. They're stepping on each other's toes, and it's really hard to manage larger teams, right? That's why there's a whole software engineering course that teaches you how to deal with people in large teams, right? So it's non-trivial. So yeah, if it's, I mean, we might be a little more lenient for folks that maybe are working just on their own, right? And we might go easy on you. But in general, in principle, right, we're not going to distinguish, how to grade folks that depending on the size of the team. Okay. Right, so this is the to get an A, you have to get at least a 94. If it's a 93.5, that's a 94, right? So this really should say 93.5 and above, right? That's a 94. That's rounded to the nearest whole number. So we do that. We do round, the nearest decimal, half decimal, right, to the next whole number, and that's what you get, right? So if you have a 93.8, you can assume that's a 94, right? And you got the A, right? So that's same thing for everybody else. Late submission, I think we have a pretty simple late submission policy. If you're going to be late, right, and you think you might need a couple more hours to finish up and wrap up and just clean up a little bit, that's fine. You don't ask for permission from the TAs or myself. Just take those 2 hours, right? 2 or 3 hours or whatever. What we're just going to do is that whenever you submitted it, however late you are in submitting it, we're just going to deduct that many points, right, from whatever you would have gotten. So we'll first grade it as if it's not late, right? And if you were 3 hours late, we're just going to deduct 3 points from whatever you got. Okay. Now there are exceptions. If you're sick, right, or you had some family issues that you have to deal with, and then we're certainly going to be supportive of you. And so just let us know. I mean, there are everybody has some really hard times sometimes. So we'll work with you and support you any which way we can, including waiving the late submission policy. Okay. Just let us know. Also, I know that some folks are traveling either for sports or they're going to conferences and things like that. That's also a legitimate reason why you might need an extra couple of days or not. And so again, we will work with you if that's necessary. Assignments. So assignments are meant for you to work on your own, right? Whereas team projects are meant for you working for teams, right? Obviously. Quizzes, projects. So academic integrity, please don't put me in the very uncomfortable position of having to, report you in any way about, plagiarism, whatnot. We're all adults here. Please, try to be trustworthy, and don't give me any reason to doubt that whatever you're working on is not your own, right? Especially on assignments, quizzes, projects. Obviously, you're going to be working with other folks. Now, I do provide a lot of source code from either, I do a lot of live coding, and you're welcome to copy or reuse any of my code that I provide in my own GitHub. But no one else's, right? So not any other students. It's okay that if you find some quirky little algorithm on Stack Overflow, that sorts stuff or does some fancy mathematical computation or whatever, that's fine, right? If you copy code from there, as long as you give it an attribution, right, and say, hey, I got this from whatever, right, Stack Overflow, and so give credit where it's due, and don't try to pass it as if it's yours, right? So don't try to deceive the grader or myself or the TAs. Just be honest about it, especially if it's code that it has nothing to do with what the assignment is or what the project is or what you were asked to do yourself, right? If it's something else, then sure, feel free to copy and just put an attribution where you got it from. Okay. Here, just be honest about it. Also, yeah, don't go and searching for past repositories from past semesters on what other students might have done, what other projects they might have done, right, and copy from there. Please don't do that. The TAs are, have been with me. Some of them have been with me for the last couple of semesters. They've graded some of those projects in past semesters. They're, if they see something that, that looks fairly similar to what they've done in the previous one, they're fairly good at finding those things. Again, please keep it honest. Right? I am required by the university to report any suspicious activity. Because I guess they keep track on if students might have been reported on other sections, on other classes, right? And they see a pattern, right? They'll come and discuss that with the students. So I'm required to report any weird activity. Okay, so please don't give me any, especially in the spring semester where folks are graduating, right? And you have family coming over and seeing at your graduation party and blah blah blah, and so and this has happened to me, unfortunately, that I had to report somebody and people are crying. My grandmother's coming to see me graduate. Oh my goodness, right? Please don't put me in that awkward position. Okay, that I start crying and horrible. Anyway, so please keep it respectable, and if you have any questions, please feel free to stop me, interrupt me, and we can go over things. Again, don't feel that any questions is stupid questions. There are no stupid questions, right? Just it might be a stupid answer, right? But but if you need we can go over things over. And beyond the office hours that I am providing, I if you need to do like a one-on-one, sure, you can I will provide my my personal phone number. You can text me, right? And you can and then we can set up a one-on-one, right, on other times that might be good for both of us. Okay. All right. Any let's see, any questions so far? That was a lot. All right. Let's see. Do you know whether the core for Macs would matter for this course, i.e. Intel versus M1? I don't believe so. No, I mean I have an M1, and all my source code compiles and runs fine. If there were some encryption or where you have to obfuscate passwords and things like that, or like an open VPN or things like that, or that might have been an issue. But yeah, we're not going to use any of those libraries that go into the low level implementation. So yeah, no, it should be fine. All right, let's see. Okay, so Piazza, final project requirements. We'll go over final project requirements a little later. There is a required text, the office hours, GitHub. I will be sharing all my source code here on my GitHub, and we'll be posting it later for everybody. So yeah, so the first week, there are a couple of readings for this week. If you could please read those first, or maybe just the first chapter is enough, but second chapter a little later. Let's see. Will the class code for text? Wait, what is the class code for textbook access? I didn't know that there was a textbook access. I'll find out.
That was my question. Maybe I'm not doing it right, but I did get like my code when I bought the book, but then when I tried to go to the website, they were asking me to like join a class to then put in my code, but maybe
Okay.
that's not the
I'll
right
find
place.
I'll find out tonight, and I'll post it on Piazza for everybody.
Thanks.
Will all three class content be consistent? Like if we want to join Yeah, so I will make an effort to maintain all classes at the same pace with a consistent material. So yeah, you should be able to come to any of my lectures. For the graduate lectures, I will be going into material that I'm not going to cover on the undergrad. Especially for in the assignments, there's sections that are specific to the graduate students. Also for the project, for the final project, there are some things that I ask of graduate students that I don't ask for undergraduates. So that might be the only difference. But for the for the core content and concepts, it should be similar. To have issue exiting the piazza, can you please check? Yihu. Okay, Yihu. It's the link to the piazza. Let me just send you a link, and maybe you can. I think you can register yourself. So I'm just gonna send you a link to the class, and you should be able to join yourself. So here it is. So try that, and you should be able to register yourself. And if not, let's table that to at the end of the class, and we can take a look at it together. All right, so let's talk about web development, installing Node.js, and getting started on the first assignment. Okay, so let's introduce what is web development. All right, so web development. All right. Okay, so what is web development? All right, so first of all, what is web? All right, so the web is a software infrastructure that is running on top of the internet, right? And then web development is implementing applications using that technology stack, right? That framework. But that framework sits on top of the internet. So let's first talk about the internet, just a little bit of background history, where and why the internet exists. So the internet exists, us trying to survive World War III. So basically at the end of World War II, folks at the War Department, were analyzing, how do we beat the Germans, right? How do we win World War II? And it turns out that we bombed the heck out of it, right? We destroyed all the roads and telecommunications, phones, and radio stations and whatnot. So, and so we made it really, really hard for them to be able to communicate and coordinate their efforts. And so we were concerned that we might be victims of the same strategy, right? And so the government asked the War Department or the Defense Department to take a look at how can we build a system that would be robust and redundant enough that that there would be no single point of failure that you could bomb, right, and would make us unable to communicate with one another and coordinate a response, a defense, right? So the military went on and started doing this research in the 1960s, alongside with all the road systems across all the interstate system that crisscross the United States. It's also us trying to survive World War III, right? How do we escape from the metropolitan areas if they were going to be bombed with nuclear weapons, right? How do we escape from and there's no way to escape that, right? But anyway, so that effort kind of there was a lot of investigation, a lot of research, a lot of infrastructure that was built over the next several decades. And so in the 80s, the ARPANET was one of the initial versions of the internet, which was entirely military. They started opening it up to academia, letting universities in, research institutions all over the world, connecting to this network. So it was just basically a network of networks, right? Of ever larger networks of within an institution, and then be able, within multiple institutions, right, and connecting those institutions with one another, right? And so how is it that we can uniquely connect to a particular computer, very much like we can call a particular phone, right? Particular phone number. I was going to talk to an individual phone. Here, there's each computer gets a unique IP address, so I can choose any particular computer on the network if I know their IP address, right? So anyway, so in the 90s, there was a lot of commercial interest on the internet, and then and there was the and after that, it just exploded on its own, right? So the web was invented by Tim Berners-Lee at the end of the 1980s, and there were all the infrastructure was there, right? We already had mechanisms for transferring data or files of any type of file within machines. We had applications that could open up those files and render them either as images or PDFs, or compile them into some kind of viewable page, right? So we already had that, but it was all sorts of disparate tools that you had to use to transfer the file and then compile the content and then view it. It was all very cumbersome, right? So what Tim Berners-Lee did is he said, okay, well, I want to simplify this a little bit. So he standardized in a particular technology for formatting the document. So he chose HTML or hypertext markup language, right? And he built the first browser, he built the first servers, right? And what he was trying to do was something very simple, right? He was a physics researcher, and he wanted to be able to share his research results with other fellow researchers, right? And he wanted to have an easy ASCII all text way of formatting the content, right? He wanted to be able to do headers and paragraphs and tables and lists, right? And show some images. And so he wanted something simple that could be edited with just simple text, right? The solutions that were already being used use very hard to read, very hard to compile, very proprietary ways of formatting the content, and not easy to use, right? So he said, well, I'll use this ASCII, this HTML, or this XML based language called HTML that he invented it. It's a particular dialect of XML that is for formatting documents, right? And he wanted to be able to in this documents be able to link multiple documents, so that if you're reading the document, a research paper, usually research papers have references to other research papers that they are based on, right? So that you could take, you could say, I'm saying this, not out of thin air, but so and so said it, right? So I can reference those documents, right? So he wanted to make a good mechanism that you could quickly click on that reference, right? It would go fetch that other document, would display it, right? And then you could quickly come back to the original document, right? Navigation. And so he invented this or copied some of the ideas. These were all ideas that were in the ether, right? Lots of people had all these ideas, but it was Tim Berners-Lee, who first put together all these ideas into one single consistent framework, right? That made everything so easy, right? So he built the first browser that parses HTML, that can render hyperlinks, right? That you can click on the hyperlink and navigate to other HTML documents, right? So the browsers could talk to a server, an HTML server, HTTP server, who can retrieve the document for you, download it, right? And the browser could then render it for you, right? So he built all this, and so it lowered the bar of creating content, very, very low, right? And so it became extremely popular amongst all academics, right? And then obviously this just exploded exponentially. The content has been growing ever since, right? So just a few milestones to be aware of, right? In the 1960s, The government works on the internet, right? The framework that connects all the computers of the world. We based on a specific roles that computers would have, right? Some computers would have the role of being the server. Some computers would have the role of being a client. So back then, right, usually most computation was done on very big machines that were in, air conditioned, rooms. There were these monolithic machines, very powerful. And then you had multiple small little tiny terminals, dumb terminals that connected to this mainframe server, right? And all the work was done by the server. The client was only responsible for rendering the response, right? But all computation was done on the server. So client machines would send requests to the server. The server would compute that response, right? The response would come back to the client, and then you would get render the response on the client. So then in the 80s, right, Apple Computer and and IBM came up with the idea of personal computers, where now instead of having this big old mainframe, you could now machines were cheap enough and powerful enough that I could pick it up and take home, right, or put it on my desk. And then so now that changed the paradigm quite a bit. Now instead of having software running on a centralized server, right, now software could run on my desktop, right, without a server, right? So now everybody was sending floppy disks and CDs. I'm sure you never used CDs for distributing software, but that was how we used to. And you put in your CD, install the piece of software onto your machine, right? And so updating it was a mess, right? You had to do another CD, right, and upgrade. So personal computers. And so now when the World Wide Web came in and web applications, the pendulum kind of started swinging back to servers, right? It was usually so we'll get to that in a minute. So the World Wide Web comes up in the late 80s, early 90s, right? People start posting all sorts of static content, magazines, newspapers, maps, images, right? Lots of videos of cats. So it's just the content, it just explodes, and folks and a lot of commercial entrepreneurs and companies start to be interested on the World Wide Web and see how we can monetize it, and so they're pushing the limits of what the World Wide Web can do, and so they start looking for being able to increase its potential by adding computation, adding automation, network, miniaturization. So by the 2000s, early 2000s, late 90s, 2000s, there was a recognition that the World Wide Web is really a framework that allows you to build entire applications, not just static content, right? It's things that you can interact with, right? You can have dynamic content generation. I can generate content. Blogs explode. Everybody had a blog, right? News blog and whatnot, and so there's a lot of frameworks that start to coalesce around the idea of being able to implement web applications, and then we had the mobile computing revolution in the 2010s, right? Where instead of having a desktop computer on my desk, now I have a supercomputer on my pocket, right? So I can take it anywhere. I'm always connected, and now these applications start to look how they can be rendered on both small screens, large, medium screens, larger screens, right? We enter the big data explosion where folks are generating lots and lots of data as and being stored on large data centers to try and data mine some patterns, some behaviors, right? Try to sell you something, right? Where are we going later? Who knows? Neuralink, Starlink, TeslaBot, Chat GPT. Anybody play around with ChatGPT? That's scary. Who knows where we're going? So on the server side, right? While this is happening, right? This is the overarching technology shifts that are happening. Several things are happening on the server side. So technology companies, right, start to appear. Right around personal computers at the beginning of the World Wide Web. Folks are starting to look at this as a big opportunity, and there's a lot of investment going in on companies that want to use the World Wide Web for all sorts of things, right? And so they're looking to say, well, how can we make the content more dynamic instead of being static, right, and just being a magazine or newspaper where the content is static? How can we make it dynamic, right? So for instance, if I want to make a weather app, I want to be able to over time show that now it's rainy, right? Now it's cold, now it's hot, now it's cloudy, right? And now it's sunny. So it changes over time. So how can I make it so that the content changes over time every time you come and visit, right? And it can programmatically decide what to display. So that idea gave way to thinking about if a browser is asking for a web page, that web page, how can we make that web page be dynamic, right? Because right now those web pages are just HTML ASCII text, right? It's just XML. They're not dynamic. So somebody had the idea, says, wait a minute, instead of the browser asking for this HTML ASCII piece of text, how about, right? I mean, the browser is expecting that, right? The browser is expecting HTML because that's what it knows how to render, okay? But it doesn't have to be a file. It doesn't need to be a static file, right? It could be a program that runs on the server, and then it can add the output of this computation, right, can be HTML, right? So that we can respond to the browser with HTML, but instead of being static HTML generated, stored in a static file, it could be HTML that is computed, right, with an algorithm, right, implemented in any language, Perl, C++, any language, right? So this idea just took off like crazy, right? And one of the more successful implementations of this idea was PHP, right? Where that allowed you to embed, HTML interspersed with a C kind of language, right? That allow you to dynamically, iterate and generate, lots of HTML programmatically, right? And so that was a boom, right? So PHP was a huge boom from '93 to the end of the '90s. In the late '90s, so there was an effort to standardize, some of the patterns, some of the best practices of what to do, what not to do, what works well, what doesn't work well. And so Java was the first framework to come, and the Java 2 Enterprise Edition, or J2EE, was the first framework that kind of tried to bring together all the best practices on how to build large web applications, right? And so introduce a lot of design patterns, such as the singleton pattern, the front controller pattern, the model view controller design pattern, right? Data access object design pattern. So all these design patterns were implemented or introduced in the late '90s and early 2000s, right? Then there's the .com bust in the early 2000s. Everything went to hell. Nevertheless, all this technology kept evolving over time. .NET made its own version of the model view controller, but using their family of languages, C#, Visual Basic, ASPs, and whatnot. There's a plethora of other iterations on the same idea, right? These all have in common that these are server-side solutions that what they were doing was saying, I want to generate that the HTML that browsers render, I want to create that content on the server programmatically, right? And then pump it down to the browser for the browser to render, right? So the pendulum, the technology pendulum swinging back to the centralized server idea, right? So this was in the 60s and 70s when we invented the client server, right? Then we went to the personal computer away from the centralized server. It is kind of swinging back, right? The technology pendulum back to the server side, heavy computing, generating content, right, on the server side, right? So all these solutions looked to do, implement that idea, right, of generating HTML on the server side, right? So on the meantime, right, or in parallel to this, right, there's also things happening on the browser side. So there's a lot of technology, happening on the server, but also on the browser side, right? There's a lot of new ideas on the browser side or the client frameworks. Which the first one was JavaScript that developed by Netscape, which the idea was that, hey, browsers can execute code, right? You could run source code written in a specific language, JavaScript, and browsers could run that, and to do things on the browser, right? Now, folks at first balk at this and say, wait a minute, I'm going to have a browser running on my machine. It's going to go out to some server that I don't know. It's going to download executable code. It's going to run it on my browser, on my desktop. No way, right? People got scared of that and says, no way am I going to download somebody else's source code, right, and run it on my machine. That's a huge security risk. So this was a little bit of dead on arrival, the idea, but little by little, they address all the security concerns for JavaScript, saying, well, no, the browser is going to make sure that if it downloads this code from a server and it's going to run it on your browser, it's going to have some limited capabilities, right? It's not going to be able to peruse through your file system, right? It's not going to be able to go looking for passwords or access the file system at all, right? So there were a lot of limitations that were given to the browsers, right, to appease a lot of the security concerns. But Java was mostly limited to doing some really simple stuff on the browser, like maybe like validating forms, right? If you're asking for text or numbers or dates, right, when you're filling out a form, JavaScript can programmatically validate your form, highlight what's wrong with your content, right? But it was a huge opportunity, right, of what could you do on the browser that you don't have to do on the server. And that was a huge opportunity that was seized by Adobe, right? Adobe seized this opportunity and said, ooh, things could happen on the browser, right? I could implement some code that gets downloaded to the browser, and the browser can then execute it. And they totally skipped the JavaScript solution. They said they said, no, JavaScript is not strong enough, not powerful enough. Instead, we're going to ask folks to install a plugin, and folks are going to be able to download an executable, right, written in a specific language, in a mature language, very well defined, very well vetted, and then they're going to run that on their browsers, right? And this was very successful, right? Adobe dominated this, for almost a decade, right? And everybody was playing all sorts of Adobe Flash games and presentations and all sorts of 3D stuff and games for kids, and it was a huge success, right? But meanwhile, right, folks were still experimenting with JavaScript. What can we do with JavaScript, right? JavaScript is the native language that can be executed by the browser, right? As opposed to Adobe was not native, right? You had to install a plugin to be able to execute these things on the browser, right? So folks were still investigating what can we do with native JavaScript. So, and there were a lot of understanding that JavaScript was not a very good language, right? It was not a very mature language. It was not really an object-oriented language. It was sort of like an object-oriented language, but not really, right? It was not typed, right? It was a runtime, so it was really hard to debug, and it was really easy to get it wrong. You had to do runtime debugging, right? So there were a lot of frameworks that were built around JavaScript to kind of fill in to make the language a little more mature. Dojo was one of the first forays into that and creating a nice framework. jQuery definitely solved the splintering of the language from multiple vendors and the multiple versions, right? So jQuery was able to do that. Knockout also, but it wasn't actually until Angular, Google's Angular in 2010, that really there was a huge step forward on the level of maturity of frameworks that we can actually start building applications that run on the browser, right? There was a lot of things a lot of very exciting things were happening on the server side, starting a decade earlier, right? Where Java and .NET were doing amazing things with very, very mature frameworks, and so these other frameworks were kind of like maybe like a decade late, right? And but they were copying a lot of the good ideas from the server side, copying those same ideas onto a browser side, right? So for instance, Angular copied a lot of the same design patterns that you have on .NET and Java, such as singleton pattern, services, caching, navigation. Did I say services? Yeah, component-based technology. So they really made a really good effort at creating an overall framework, but for the browser, right? They did, though, make a huge blunder when they went over to the version 2 of Angular, right? And really made everybody very mad about it, since the version 2 of Angular applications was not backwards compatible with version 1 of Angular, right? And so a lot of businesses were resistant at porting their applications written in Angular 1, porting it into Angular 2, right? Because there was a huge investment that they made in Angular 1, and they just said, what do you mean I have to rewrite everything? Nothing that I wrote is forward compatible with what's Angular 2. Oh my goodness! So they started, considering it. Says, hey, if I'm going to have to rebuild this, rewrite all this, what else is out there? What other frameworks are out there? And indeed, there was a nice little framework, not really framework, a library, nice little library, React.js from Facebook, that was ready to welcome all these gruntled developers and companies, right? And that's where React.js started to take over the world, right? And is right now is one of the leading libraries for rendering content on the web, right? And that's where we're going to be spending most of our time the first half of the semester. Okay. And this is the architecture that we're going to be using throughout the semester. The client, this is going to be the browser, right? The code running on the browser, which the client could be anything, right? It could be a desktop application, or maybe for games, or but we're going to be using browsers as our client, and they're going to be running HTML, CSS, JavaScript, React, not Angular, not Vue. You can explore that if you want for your project, but not in the assignments, right? On the second half of the semester, we're going to be focusing on the server, right? A Node.js server. In older versions of this course, I used to use JBoss or Tomcat, and for the backend, I used to use MySQL. We're going to be using Mongo for the database, but this is the architecture, right? You're going to have your browser running a React application, right? Which is going to be connecting to a server to fetch for data, right? And then the server is going to respond with HTTP, JSON, for us to render the content on the client. Okay, and so here's just a little bit diagram that illustrates the difference in on how server-side solutions and client-side solutions, how they differ, right? And how they can work together as well, right? So the server-side solutions, right? These frameworks work as follows, right? If Alice is requesting a web page, right? That browser, instead of asking for a static HTML document, it can ask for some executable, right? Or either implemented on ASP or JSP or PHP or Python, right? And then the server finds that executable, executes it, and it generates, computes the HTML, and then spits back the HTML as if it were static content, right? The browser can't tell, right? It just sees the HTML and then it as ASCII content, right? And it renders it for Alice, right? And this was the de facto way of implementing, dynamic web applications for a good, 15 years. Okay. Today, the more modern approach is that instead, if Alice is requesting a page, the server responds with HTML plus JavaScript, right? HTML templates and JavaScript. The JavaScript executes on the browser, so there's no executing on the server. See that? I'm just responding with static HTML, static JavaScript, right? But now the code executes on your browser, and the browser and JavaScript on the browser manipulates the content on the browser, adding content, removing content, changing fonts, changing background color, right? Doing all sorts of styling. Now, if it needs data, right, because there is no data here, right? It is free to go back to the server. Say, hey, server, I need some data, right? And so the server can respond with that data, and then the browser can then use that data to dynamically render that content, right? So today, this is what the modern web applications work. Some applications use both, both implementations. They'll use this implementation for content that needs to execute fast, that needs to be pumped to the front end as fast as possible. For instance, maybe like the landing page, right? Where you don't want to, if you use this approach for the front for the landing page, it might be that you come back with some template with some content, right? But then you don't have any data, so a lot of the content is empty, and maybe you have a lot of spinners, right? While JavaScript is going back to the server, fetching some data, and then coming back and then rendering it. So, and that might take half a second, or maybe 1 or 2 seconds, but it might be too long, right? And the user might get annoyed and navigate away from your page, right? So usually some very high performance content might still use this approach, where the content is pre-calculated, pre-computed, or computed by very powerful machines, right? That can compute the HTML very, very fast. Almost the server, the browser would not even know, right, that this was a static HTML document. It was so fast, so lightning fast, right? So today you see some combination of both approaches in modern web applications. Okay. All right. Let's take a short break. And I would say maybe 5-10 minutes, and let's stretch our legs. Maybe do a bio break, and we'll come back and keep going. All right. Please don't go anywhere. please come back. Can you all still hear me fine? Yes, Sophia. Just FYI, I was able to solve my question. The access code I had was. Okay, awesome. Thank you. Thank you, Sophia. All right, I'll be right back. I'll be back in about 5 minutes. See you in a bit. Hi, can you hear me? Okay.
Yes.
All right, awesome. All right, let's see. Make sure it's recording. Sharon, can you see my screen?
Yep.
Okay. Yeah. So let's get started. So just a little bit on the assignments. Just want to make sure I cover the assignment, and so to get going with that. Okay. So this is the first assignment. So the first assignment is to set up the development environment, which includes installing a development environment, which it's it could be Visual Studio Code, or it could be IntelliJ. I'm using IntelliJ, and it's a pretty cool IDE. It might have a too big of a footprint for some. It is a memory hog, but it's fairly full. It has a really cool debugging, but certainly Visual Studio Code is an excellent alternative. So please install one of those two. Also, this is what we're building, right? We are going to be focusing mostly on the front end, the first half of the semester, and then the second half of the semester we'll be focusing on this second half here on the database and the server. Now, for both we do need to install Node.js as a framework, right? So Node.js is a Node.js. Let's open it up. It's basically an infrastructure that allows you to run JavaScript on the desktop. Okay, whenever you think of JavaScript, usually we think of running code on a browser, right? The browser downloads JavaScript, right, and runs it inside of the browser, and that's true. That was the case for the the first decade or two of JavaScript. But in the late 2000s, 2008, 9, the Node.js freed JavaScript from the browser, right? It now allowed us to run JavaScript on a desktop, right? Just from the command line, and so now you could write code that was not constrained by the browser, right? Because before, right, because of security concerns, folks kind of limited what JavaScript could do inside of a browser. It could not read or write from the file system, right? It had limited network connectivity. There's tons of things that it could not do. There was tons of things that could do, right? It could render a front end, right? It could play lots of cat videos. It could validate your form. You can make games running on your browser. But you could access databases. You couldn't access the file system. You couldn't do network communication. By freeing it from the browser and now being able to run on a desktop, and now you could write code that had access to the file system, right? Had unfettered access to the file system. It could do anything that any other language could do. right? It could connect to databases, right? It could connect to network systems, right? It could do whatever other languages could do. Now it could do as well on the desktop, right? And so this dynamic of JavaScript running on a browser and now JavaScript running on a desktop, right? That's a very powerful combination, so that they complement each other very nicely. So that the things that you could do on the client on the browser, but you cannot that you can't do on the server, right? They complement each other, right? And things that you can do on the server, you can't do on the client, right? They can each do the things that the other one can't, right? So yeah. So also the front end that we're going to be building, right, uses React.js, and React.js is written in a very high level language, right, that needs to be compiled or transpiled into lower level JavaScripts, right? And the way we do that is through Node.js. Node.js, we're going to use libraries that allow you to compile or transpile, high level JSX, JavaScript, XML into lower level JavaScript that can run on any browser, right? So, and that is done through Node.js. So one of the things that we need to do is install Node.js. We need to install Node.js. You can install it from here. The latest, either one would be fine, right? 18.13, that's fine, right? And so yeah, so we're going to be using HTML for building the web pages, CSS to make it look pretty, JavaScript to control the browsers, but then JavaScript on Node.js is going to allow us to run the JavaScript outside of the browser, right, on our desktop. Okay, so download Node.js, install it. Even if you had Node.js installed previously in previous semesters, please update it to the latest Node.js, and you should be able to test it to see the version of Node. This was version 4.14. I think I have the latest. What I have here. All right, so I have version 18, so it's almost the latest one. And so what we're going to do with Node.js, once you install Node.js, and let me write the assignments. Once we install Node.js, we are going to be able to install other things, right? For instance, we're going to have access to Node.js's npx command, right? There are going to be 3 commands that we're going to be using quite a bit. One is Node itself. Node allows you to run JavaScript files. So for instance, if you have a hello.js file that says hello world, you could run it saying node hello.js. Okay? The other one is npm. We're going to be using it a little later, which allows you to install libraries, and there's tons of libraries, right? The interesting part about any language or any framework is not the language itself. Languages are pretty lame on their own. What's interesting is the various libraries and components and community that is that surrounds that particular language, right? In JavaScript or Node.js, JavaScript running in Node.js, there's tons and tons open source libraries that are hosted at npmjs.org. And notice that it starts with npm. npm, right, is the package manager. npm is Node Package Manager, that allows you to install libraries or components, right, that are being hosted right here in this repository. Okay, and anybody can post to this repository. There's tons of folks that are working on open source projects that will host this. Posted here for free, and you can see what are the most libraries that are most popular. One of the more popular libraries is this one, the Express library, that allows you to implement HTTP servers very quickly in just a few lines of code. You have an HTTP server up and running. We will do this the second half of the semester. For now, we're going to use another package called create React app. So create React app is by the Facebook folks, okay? And what it does is it's a library or module that you can execute it and generate a boilerplate ready to run out of the box implementation of a hello world React application. Okay, it's a good place to start. Now you can use it in a couple of ways. One of the ways is to install the library or the module on your desktop, right? And then you by doing npm install. So again, npm is Node's package manager to install new packages. You can install that and then use create React app to create multiple applications. Another way of doing it is using npx, right? npx does not install the package. Instead, it runs it right away, right? Well, obviously it downloads it so that it can run it, right? But then it doesn't stick. It doesn't stay within inside of your environment, right? So that's what we're going to do. We're going to use npx with no I, x for execute. And that's what the assignment asks you to do. Let's see. So first it asks you to create a directory where you're going to be doing all your work locally on your machine. So let's do that. Let's see. Let's go into 2023. We're going to go into Spring. Okay, so I already had a lecture earlier this morning for CS 4550. I'm going to create a directory for you folks. And for you, I believe, let's see. Oh, I think your section is section 6, right? So I'm going to create CS 5610 and then 06, okay, for your section. And let's go in there. All right, there's nothing in there. And in here, I'm going to follow the instructions. The assignment actually tells you to create a Spring web dev. I'm using the name of the course, right? Because I'm going to have 3 different versions of this. And then in that directory, which there's nothing in it, we're going to create this application, right? And the application that we're going to create, this says npx, this says run this command, right? This module, download it, run it, but don't keep it, and create a new application called as follows, called Twitter. So we're going to be creating an application called Twitter, right? And the name I'm giving it is a React, just to know that this is a React web application. So this is going to be the front end of a Twitter application. In the second half of the semester, we'll talk about creating a Twitter Node server application, right? And we're going to have them talking to each other. But for the first half, we're only going to focus on the front end. Okay. I'm also going to append here the fact that this is CS 5610 and that this is 06 and that this is Spring 23. Yeah. So I can create that. So that's going to take a couple minutes. So let's leave it. It's going to create a new directory and it's going to download all the source code, all the templates, all the libraries, right, that implement a boilerplate React application into my my system, right? So while that is going on, we are going to want to create a source control. We are going to want to share this source with the TAs and myself, and so also so that we can deploy it so it runs on a remote server. And so I'm going to create a GitHub repository with that same name. Let's copy that. So while that's going, I'm going to open up a new folder tab here, and we're going to go to GitHub. And I'm going to create a repository with the same name as the name of the our application. Uh-oh. Huh? What? Oh, I copied it. paste that. All right. Okay, let's do that. Please do follow the same thing, right? But you could keep it just without that, right? I'm only adding that so that I know which section this is for. You can just call it Twitter React Web App. Okay. Leave it public so that the TAs can come and take a look at this. So you don't have to invite them or anything. Don't worry about people copying. People are not going to copy you, of course. So create the repository.
Hi, Professor.
Yes.
Sorry, maybe you already mentioned it before, but just wondering for the GitHub, can we use our own one or we should use the one from school?
I would rather you use the github.com, the public one, not the school. The school has some limitations because it's an enterprise GitHub, and sharing it with others outside is somewhat limited. So please use the regular GitHub.
Okay, thank you.
Yeah. Okay, so that should be done, right? If we go inside that directory, we can run it right away using npm. So npm is used for quite a few things. It's used for installing libraries, compiling, running tests, and also running your application. You would say run npm start. So npm start is going to kick off a local Node.js server that is running at port 3000 and is going to run our React application. And there we go, right? So there's the boilerplate React application that is their hello world version. Okay. So anyway, so we created this. We created the repository. We're going to add all our source code to this new repository so that we can share it with the TAs and myself, so that we can grade you, and also so that we can deploy it to the a remote Netlify server. Okay, so that's running. And so in a separate tab, I guess, let's can I start creating a tab? No? Yes, different PowerShell. Okay. Let me go into that same directory. 2023 spring, yes, and then Twitter. Okay. So in here, if you look in here, this is what the our npx did, right? It created this directory containing the following, right? One of the things that it's in there is our node_modules. That's a folder that contains all the libraries that our project it needs, right, to run. And so those libraries should not be added to your source control. No, you should never put in source control any libraries or compile code, any binaries, .class or .object or zip files or jar files, things like that. That should not ever go into your source code. Only source code should go into source control, right? And that source code is inside of public and source, right? All this is source code, right? Now these two folders, they contain source code. The public directory is a standard name for HTTP servers that, like the name suggests, is whatever you put in that public directory is going to be publicly available through the server. The server is going to make available all the files, right, that you include in that public directory. Anything outside of the public directory is not public, right? The server doesn't know about it, right? It doesn't make it available. Now, for a React application, the source directory is a complement of the public directory, okay? Is where it contains all the JavaScript source code, right, that implements the React application, right? So we're gonna wait on that for a couple of weeks before we delve into the source directory. We're going to spend the first couple of weeks inside of the public directory implementing just static HTML, static CSS, right? Just static content, just as we get our bearings on what all this means, right? Once we have a minimum set of skills, then we'll move over into React.js, right? Git ignore right? This gives it away that this is a Git repository. Now, if you have, so if you have, do I cover that here? Where's assignment? Okay. If you, so one of the things that the assignment asks you to do is to make sure that you have a Git client, right, installed. If you have a Mac, you should already have a Git repository, Git client installed on your Mac. If you have a Windows machine, you can download a Windows executable to run Git on your Windows OS. Also, if you want to use a nice graphical representation of your Git repositories, Source Tree app, is a really nice front end that runs for both on Mac OS and Windows. Here, I'm making sure that you're not going to include in your source any compiled classes, right? Any libraries, things like that. Make sure that gitignore includes node modules, node underscore modules. And we can take a look at what's in here. More dot gitignore. So we see that it's already in there, right? So node modules is there already. So we don't need to include it. But we do need to include, I haven't opened this directory yet with my IDE, so it's not included in here. But when I open up with my IntelliJ, it's going to add a folder, right, or file for my IDE. So that should also not be in your repository, right? Because I might be using IntelliJ, someone else might be using Visual Code, right? And so those files are irrelevant, right? They're only specific to your particular environment, right? So that should not go into source control either, right? So let's do that. Let's open it up with IntelliJ and see that it creates that additional content that we don't want. So let's open and Spring. There it is, this one, Twitter, open. Okay, so if you go back here and now you're doing ls again, notice that now you have a .idea. See that? That was not there before because now I've opened it up with my IDE. Right. So what we're going to do is that there's our folder. We don't want to include that in our repository. So in the gitignore, we're going to append the there it is. In our gitignore, we're going to add here dot idea. We don't want that either. Okay. All right. So there we go. So we make sure that we have node modules and dot idea in there. Now we can follow the instructions when we created the repository. There it is. So we're going to just follow these instructions. We're going to git init, right? So we already have a README, so we don't have to do this first one. Git init. Our repository, I think it's already initialized, but it won't hurt if we reinitialize it. So let's do that. Yeah, it was already initialized. So it's saying that it reinitialized the Git repository. The way that there's a Git repository is that notice that there's a .git folder here that it's hidden. You can't see it. But if you do ls.git, you see that folder is here. It's just not being shown, but because it's hidden. But if you have that folder, that means that this is a Git repository, right? Which probably already had it. That's why it says that it reinitialized it, which is okay. We're going to add everything, not just README. We're going to add everything. So we're going to say git add everything. Okay, that's fine. It's a warning. So we added that, and now we're going to commit. This is going to be our very first commit, which is good. Done. We're going to change from the branch because right now the branch is master. That's the default name. And we're going to change that to be main instead. Right. So let's change that. So -m changes the name of the current branch. So I'm going to change it to main. If we say git branch again, you'll notice now that the branch name has been changed to main instead of master. Okay. So we're going to add this remote, this Git repository that we created here on GitHub, which that's the name of it, right? We're going to add it as a remote. See that? So this says git add this repository and call it locally as origin, right? So I can refer to it as origin. So there it is. So origin is a special name in Git, right? It's the default name of a repository, meaning that when you refer to it, you can refer to it by omitting the name, right? Like for instance, if I say git push or git pull, right? It's understood that you mean this repository, right? The default repository, right? You don't have to explicitly say origin, right? It would be redundant for you to say, git pull origin. Okay. Now, if you can have other remote repositories with other names other than origin. Now, those other names are not default. Okay, so that if you want to pull or push to all those other repositories, you have to explicitly use those names, but not origin. Right. So by saying that this is the origin repository, I'm saying that this is the default repository, which I don't have to name, right? Whenever I refer to it. Okay. So now I can just push my main branch to the origin repository. So this is going to push everything to the Git, my remote GitHub. So if I go back to GitHub here, if I go back here, notice that these instructions only are shown the very first time you create the repository, and it's empty. There's nothing in it. Nobody has put anything, but now there is. Right? I just pushed, and it says I pushed the content, right? And notice that it says, yep, I pushed all that stuff in there, right? And several kilobytes of stuff, blah 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 blah. I push everything. So if I refresh this, now, the instructions are going to go away. They're never going to be available again, right? Because now there's content, there's real files in here. So I'm going to refresh, and now this content is identical to the content, the local content, right? Except that we don't have these files, these directories. They're not there because we don't want them there, right? They should never make it into the remote repository. But we do have public, right? We have public, we have source, right? We have .gitignore. We also have the package. Now, package.json kind of gives it away that this is a Node project that was created for a Node server, for a Node infrastructure, right? It gives it away. And it contains some of the commands that we are going to be using. So if you open up package, notice that some of the commands that I use, like start, okay, when I said npm start, it's actually this name that I was running, right? And it's using a pre-built npm library called React scripts that kicks off the Node server, right? Compiles everything, right? And it starts up the browser, right? And it loads whatever is in the public directory. Okay. Okay. We'll see that what's in here in a minute, right? But before we do that, let's continue. And so we create a remote repository. We did that. We pushed everything. We added everything, right? And then, okay. So logging into GitHub, you have to be careful. So GitHub, I'm obviously logged in, but my local desktop, right, also knows that I am logged into that GitHub repository, right? You've noticed that it didn't ask me to log in or anything like that, yada yada yada. So here I have a couple of instructions, right, on how to log in from your desktop. Okay, one of the things that it's from late last year, you can no longer log in from within your desktop into GitHub using just your username and password, right? For security purposes, that's no longer allowed, right? It's not the same username and password that you use to create the GitHub account. You have to use tokens, security tokens, right? So these instructions, I've added these instructions on how to create those tokens, right? And how to log in, right? So let me just show you real quick. here on GitHub, if you go to I think it's settings, and is it password authentication? See? And then yeah, two-factor authentication. I guess not. I don't remember. So wait a minute. So password, blah, blah, blah. If you get that error, one way to fix it is to generate a personal token, blah, blah, blah. To generate, go to settings, developer settings. Sorry. Yeah. So settings. Am I in settings? Settings, and then developer settings. Don't tell me they changed it. They did. It used to be, oh, there it is, developer settings, good. Okay, so developer settings, okay, there it is. So personal access tokens, see that? You go to personal access tokens, and then tokens, classic. And then here I have just a few personal tokens that I use to log in, right? So you can create a new token, generate a new token. Okay, it's ask me to SMS. Make sure it's me. Oh, I have it in airplane mode. Wait. Okay, and there it is. So it's 7. So you can give it a name, right? So this is CS 561006 SP23. And expiration date, I would give it, no expiration, or well, maybe no expiration, but if you give it 90 days, that's 3 months. And so it would expire right before the semester ends. So maybe you could give it a custom, or you could give it a no expiration, but just to remember to revoke it if you're not using it anymore. And then just select all the different things that you can do. For now, you can just choose all of them. You can revoke it later when the semester is over. Right, and just give it all the various powers, and it'll generate a token. Okay. Now this token, this token is now your password, right, to log into GitHub, right? So whenever you're going to try and log in from GitHub, you'll need this token. So you need to copy it, right? Copy it, and this is the only time that you have a chance to copy this, right? That you'll be able to actually see it, right? Once you refresh, right, no longer you'll be able to see it. You can only delete it, right? But I've copied it, and now I can log in, right, from my local desktop, right? So whenever you it asks you for the username and password, you can use your regular username, but then for a password, you're going to use that token you just copied, right? If you missed it, you forgot it, and you weren't able to copy it real quick, right? That's fine. You can just generate a new one. Okay. All right. Okay, so that's that little blurb about that. So once we have that, once we were able to push to GitHub, we can now are now ready to deploy our content to a remote server, right? And for which we're going to be using Netlify. Right? So Netlify, you can sign in. You can sign in with your GitHub credentials. And so I've already signed up, obviously, and you can add a new site, import from an existing project from GitHub, right? And so GitHub, you can use GitHub, and it authorizes, so it logs in, and the repo is called SP23. I think there's only 2. From Spring 23, the one from this morning and the one we just created. Yeah, there it is. It's this one. And and the branch is the main branch. Base repository, npm build, so it's going to build this and deploy. So it's going to deploy. So this is going to take a couple minutes, right? So it's going to clone the GitHub repository onto their own machines, right? And you can follow along, right? So you can take a look at this. This the current deploy. If you click on that, you can see what's actually happening. And this is useful to see if there's any errors, right? That or something that failed, right? It'll print, put it in red, saying I wasn't able to do this, that, or the other. So it's a good option to just keep looking to see if something went wrong. Notice I did not complain about anything, nothing went wrong. And so presumably the site is up and running. And so what it'll do is that it'll give you a funny name, a random name for your application, which is fine. For now, right? You would have to pay to have a some whatever name you actually want, right? So we're not gonna, you don't have to pay. So let's see. So you can go and if you go into the deployment, right? Notice that it has a URL for the application, right? And it gives you a thumbnail of what it looks like. So if I click on it, notice that now this is running, and it looks identical to what it was running locally, right? And where is it? I think it's this one. There it is. So this is running locally on my machine, and this is running on Netlify. So now I can share this with the rest of the world, maybe with you guys, right? If I to that URL, everybody can go and now visit the wonderful application I've just created. But no one can access my local one, right? If I give you my local, right, that's my local machine. Nobody can see what's running on my local machine, but everybody can see what I've deployed to Netlify, right? And that is the first assignment. The first assignment, just make sure that you have this set up, it's up and running, and you have deployed a Hello World application. Okay. Let's see, deploying, blah, blah. And so the deliverables is basically for all the assignments, right? The deliverables are always going to be the same thing. You need to give us a URL of the repository, the Git repository. So if you go back to Git, where Git, Git here. Okay, if you go back to our repository, where is it? Where's my, yeah, that repository. So you need to submit this URL, right, to your repository, and you need to submit this Netlify, right, this URL of this running on the remote server. So those are the two deliverables for this assignment. And download, okay, you did that, create React.js, push the code, deploy as deliverables. Okay, the URL to the GitHub, right, and the URL of this running on Netlify. And so I'm going to copy that. I'm going to put that in here. I'm going to update it. Fine. And I'm just going to give you the repository, the current repository for this. Copy that. And I'll just paste it in there. Okay. All right, there it is, right? So so what I'm going to be able to be doing throughout the semester, we're going to be working on the assignment using this repository, right, for the first half of the semester. And so you can follow along. I'm going to be helping out in getting started with all the assignments, assignment 2, 3, 4. I'll get you going, right, doing some of the exercises together with you, just so that we're clear on what is required and what is expected of you. And I'm going to be pushing my source code here into that repository in different branches. Branch for assignment 2 will be on branch A2, and then 3 will be branch A3, and so on and so forth, right? And you can follow along. You're welcome to copy that source code into your own repository, into your source code, you're welcome to copy me. Don't copy anyone else. How soon will you post a recording? This recording should be available later today automatically. It should be available in on Zoom meetings. If you go to Zoom meetings, once this is the ended, if you go to cloud recordings, it will appear here. Okay. I'm not sure why you have all what are all these recordings. January. Oh, interesting. Why all these recordings? I did not record these. Okay, these are the office hours. No, I didn't have office hours yet. That's weird. Okay, whatever. I'll see what that is later. So yeah, that should be available here in the cloud recordings. Okay. All right, excellent. So we're done there. Let's keep going with the slide presentation.
Sorry, Professor, I have a
Hi,
quick
yes.
question.
Yep.
Yeah, so I just noticed in the Git thing, you changed the master to main. What does that mean? And should we do that as well?
It's up to you. Yeah. Today, the word master, some folks might feel offended by that name, and so it's currently a best practice to change it to something else, a little more generic, like main. So that's what is suggested, but it's up to you. But it's a very common practice today to move away from terms that might be offensive.
I see. Thank you. Thank you so much.
Okay, so yeah, so Node.js. Let's keep working here. The next set of slides kind of like walk you through the same thing we did here in class that I just demonstrated. It's just that these are slides. They're more generic and talk about not any specific project, right? It's any React application in general, and just walk you through the various content. What is node modules, public, right? Git, ignore, right? What are the different files? Yeah, we can go over that in a minute. Yeah, let's actually go over that. Let's go over this. Yeah, let's go over this. So let's take a look at the content of what we are rendering, right? So here it is. This is my local host. See that? That's my local host. Let's see how that is rendered from the source code point of view. So let's go to my Twitter, my IntelliJ. Let's take a look at public. So public, this is where the server is fetching the files, right? And this URL is not really asking for any file. See that? It's not asking for any file. And the way this works is that the slash, when I say slash, this is a path. This is referring to a path that currently is mapped to this public directory. So that slash maps to public. So that means that from slash, I can ask for any of these files under here by specifying them. All right, so for instance, I can presumably say slash robots.txt. So say this would be robots.txt. Right, so that's the content of that file. If I open it up, you'll see that that is indeed the content. See that? So the server is the only responsibility for the server is that it maps that route, right, to public, and then you should be able to just ask for any file and just navigate to any file, to any directory that it's in there, right? And that will physically go fetch that physical file, and the server will just respond and send it back to you, right? Let's see what else we have. We have this logo, right? So if it's logo 192.png, you should be able to say logo 192.png. And indeed, it downloads that image and just displays it. See that? So that's what servers do. That's all servers do. Now, if you don't specify anything, why do we see this? Why do we see this content? Right? Why is it doing that? Well, it turns out that if you don't specify anything after a slash, it defaults to a specific file, right? It defaults to the index file, index.html file. So it's the same as if I would have actually asked for the index file, index.html. Right? It does the same thing. See that? So whether I explicitly ask for that file or don't say anything, it defaults to that one file. That's why it has that index.html is a very specific name, right? Has a standard name. You can change that name. You can say that it's home.html, right? Or root.html. So, but it's very common to use index.html instead, right? So if that's asking, so this file presumably is rendering all those things. Well, let's look at that file. Let's see what's in there. So if you start looking at this file, you'll notice that there's not a lot in here. But first of all, it is an HTML document because you can see the extension .html, and all HTML documents have the following format. They all declare a doc type at the beginning. Right, it's an XML document, isn't it? Right, but it has a very specific dialect, right? So it's XML. The format is XML, but it's using tags here that are specific, that have a very specific use case of being rendered on a browser. Right, so it has tags that are called HTML, head, body, and a closing tag. Right. So we say it's HTML, not XML, but HTML is just a derivative of XML. Anyway, so all HTML documents have this structure, right? They have a doc type at the beginning. They have a root element or tag called HTML, and which contains then two child tags or elements, right? So the head and the body, right? So the head contains metadata, right? Things such as who the author is, when was this created, if this document depends on other documents, things like that, right? But it doesn't actually contain content, right? The main content is in the body. The body actually contains the content. All right, so let's take a look at what's in the body. So the body contains not a lot of stuff, right? So this here is just comments. Just a comment, so it's not meant to be rendered. We can remove it, nothing happens, right? Remove that, and you can go back and render this, refresh, and you still get the same content. So all the content is being generated by these two lines. Well, this line says no script. That means that only render this if your browser doesn't support JavaScript. But my browser does support JavaScript, so I don't really need it. If I remove that and I re-render, notice that it's still rendering all this content, right? Something that is spinning around. You have a hyperlink over here and this edit. But where is that? I don't see any of that content. Where is that? It's not here. Where is it? So it turns out that the only thing that is being declared here is a div with an ID of root. Okay, some magic is happening here. Okay, and as I mentioned earlier, JavaScript was invented with the intention of being able to dynamically generate content, and that's exactly what's happening. JavaScript is injecting content dynamically after you render this renders, right? Somehow JavaScript is grabbing this element and is injecting content in there, right? You can see the content of any page, right? And as the resulting page, for instance, if I do press the right mouse, you get a context menu here that you can then use the inspector. The inspector is a development tool, right? That is very useful and it's going to become your very best friend for the entire semester. Always get into the habit of bringing up this inspector, okay? Which I'm going to embed here. Like that. right? And so this is kind of the behind the scenes. This when Neo in the Matrix was able to see everybody else in green and see what reality was. Remember that scene? Well, that's what this is on the right hand side. This is what the people hooked up to the Matrix see. This is what Neo sees. All right. This is the behind the curtains on how this thing is actually built. Okay. So it has several tabs here. So you should get into the habit of always having this inspector open so that you can debug, right, and see that your application is doing what it's supposed to be doing. Okay. So this there's several tabs here. The first tab is called Elements, right? And Elements is renders what is referred to as the DOM, the DOM, the document object model. It's a data structure, right? It's a hierarchical data structure that is the interpretation of the browser of the HTML document that it's rendering. Which document is it rendering? It's rendering index.html, right? Meaning it's rendering whatever's in this document. And indeed, you see the document type, right? There it is. Okay. We have the HTML lang, en, there it is, right? We have head, which we can expand. It has a whole bunch of stuff in there, right? You got meta, link, meta, link, blah, 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 which is there, right? There's meta, link, meta, right? So everything's in there. Everything's in there. And then we have body, which is this body, this opening body. And then we have this div with the root, which is this one right here. But in my HTML, it's empty. See that? It's completely empty. Whereas here, it's not. It's got some stuff in there. What is that? Who put that in there? The plot thickens, right? So all these are nodes in a tree, right? Which has a root, right? This is the root of this tree, and all these are branches, right? And JavaScript has API that can manipulate this data structure, right? That it can dynamically add content, right? Remove nodes or add nodes. So this is like an inverted tree where you have the root at the top, right? And you have all these branches and you have all these nodes, right? And then you have all these leaves at the end. Okay. You see that all these as you highlight this paragraph over here, right? You can highlight it and see the content. This is the actual content, right? This is the code. It highlights it. See that? Right? The paragraph again. You have the image right there, which is spinning, right? The header, top, right? The div, and it just highlights more and more and more, right? Or individual branches of what's being generated. So it turns out that there's JavaScript, which is dynamically adding a div with a class and another header inside. It's dynamically adding an image, dynamically adding a paragraph, right? That's being added after the fact. Where is that JavaScript? Well, notice there's a whole bunch of other tabs in here, okay? And one of the tabs is called source, right? So this source has is still content that is still inside of the public directory, but there's some magic happening. There's some magic happening here. What's happening is that the real code that runs the JavaScript is under the source directory over here, right? And I know I said that we weren't gonna get into this till a little later, but I just want to just show you a little bit on how this works, right? And then we could just put it aside for a bit and then come back to it and really dive into this. But I just want you to see some of this magic that's happening behind the scenes. You don't have to necessarily understand it right now. I just want you to understand that there's some magic happening. I'll show you a little bit of that magic, but we won't really dive into it for a couple of weeks, right? But I just want you to have some sense of it. So what's happening here is that the source, right, is where you have all our React.js magic, right? And just like we have the name index.html as the entry point of our web application, in our source directory, we also have an entry point, right? Which is index.js. See that? This is the entry point, right? And this is all JavaScript. It's all JavaScript. Well, actually, not all JavaScript, right? There are import statements that are importing other functions or libraries, right? We'll get that in a second. But here is where some of the magic starts to appear. What's going on here, right? So first of all, check this out. Here we have a document.getElementById root. See that? Ooh, look at that root. What is that? We saw that somewhere before, didn't we? It's in here, the index, HTML. See that? That ID is a root. See that? And that's what index is doing. It says it's document is a global variable that references this document. This is the document, this data structure. This whole data structure is referenced by this document variable, right? And you can do all sorts of operations. You can say, hey, document, which is this data structure, find me an element whose ID is root. See that? And so what it'll do is that it will traverse all this data structure looking for an element whose ID is root. See that? So it returns this div element, this root, this document, this node, right? So this is the low-level node that we want to inject. And what is that we want to inject? We want to inject. Notice we could say we have this is the reference to the root, and then we can say in the root render the following. Render the following. What are we rendering? Never mind these guys. Never mind those guys for now. We are rendering app. We are rendering app. See that? What is that? Right? Never mind the fact that you have these pointy brackets, right? This HTML, right, embedded inside of JavaScript, right? We'll get that we'll see. We'll talk about that in a second. But what is that? App is something that is being imported, right? And if we navigate to it, it's just basically this app.js. Right, so we go in here, it's just basically this app.js. See that? And what is app doing? It's just returning a whole bunch of HTML. Look at that. Is returning this whole thing, which happens to be what? Ooh, look at that. See that? There it is. This app, header, image, paragraph, hyperlink, all is from this. There it is. There's my app, there's my header, my image, my paragraph, my hyperlink. See that? So this div is being injected or rendered into the root, which happens to be this root. See that? Okay, so that's where the bridge happens between the HTML world, right, and the JavaScript world, right? That's how JavaScript can dynamically inject content. Now, app.js is not very, this app.js is not doing very much, right? It's mostly static content, right? But it's inside of a function, see that? So this content is being computed, right? It's calculating this, whatever the function returns returns this content, right? Which looks like it's pretty static, doesn't it? But not quite. Look at this. See this logo? That content is being, see the curly bracket? The curly bracket is referencing a variable somehow here, which is this, this SVG file. And that's how you see that the image source, it really is referencing some content here. See that? Okay. So this is being calculated wherever that file is. So let's play around with this a little bit. Okay. So for instance, I could define I can change some of this stuff. So for instance, this paragraph says edit, blah, 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 blah. You could instead say something like, welcome, welcome to web dev, right? CS 5610, section 6, right? If I refresh, notice the content immediately changes, right? Everything gets recompiled right away, and it gets redeployed in the local server, right? And you can see the output right away. Okay. You can have variables, right? So for instance, you can declare variables. You can say const a equal 1, 2, 3, and const b equal 2, 3, 4, and then you say let c equal a plus b. Okay. And then you can render these things. You can say I want to render under my paragraph for another paragraph, and I can render a. I can say a is equal to a. Right, there it is. So a is equal to 1, 2, 3. See that? So this is dynamically being calculated as a variable. Right? I can put another b equal b, and then it renders it right there. Right? There's no breaks. That's one of the things we'll learn next week. That HTML, by default, if you don't explicitly format spacing and white spacing and whatnot, it doesn't add it for you. You have to explicitly say that you want a break, right? And then maybe another break for the break, and then rendering C. Okay, there it is. You can have arrays, right? Where you can say const d contains arrays A, B, and C, and you can render d. So d is equal to d, right? So that's the array, which does include the commas. It has removed the commas, but we could render it as a bullet point, a set of bullets, right? So for instance, bullets. So there's a unordered list, which you can have several line items that render these independently. We could say, d sub 0, right, and maybe d sub 1 and d sub 2, and it renders them in bullet points, right? Or you can do iterations, right, where you can iterate over the array, right, where you might have an ordered list. And you can dynamically inject content that as you iterate over an array or an object or whatnot. So for instance, I can take D, right, and iterate over it. And as I have each item, right, render a brand new line item that contains each item, right? So there it is. So I've iterated over the array and displayed each content in a separate line item, right? So this could be a single line, right? So this is what React.js brings to the table. It allows you to seamlessly, go between two worlds, right? The HTML world that we're going to spend, all next week playing around with it, right? That is mostly for static content. And what React.js allows you to do is mix, and then we'll study JavaScript. And JavaScript is only JavaScript, right? That allows you to manipulate the content. What React.js does, it allows you to marry these two worlds, this HTML world, this JavaScript world, right? It allows you to merge them together as if they were seamless, as if they always were one thing, okay? Which they're not, right? These are two separate worlds, right? The HTML is static, the JavaScript is computational, it's functional, right? And marrying those two things is can be fairly complex, right? We'll take a look at raw JavaScript. We'll take a look at jQuery, how jQuery solved the issue, and that's going to be still way too low level, right? But we need to learn what's behind the scenes, right? We need to spend some time behind the matrix, right? What's out there, and then create this level of abstraction. What React.js does, it allows you to go between these two worlds, in a seamless fashion. Okay. All right. So what we're going to do is that we're going to not spend time with React.js for now, right? So we're going to break this application for now. We're going to break it deliberately so that we can just focus on HTML for the next 2 weeks, right? And then we'll come back to this a little later. Right? So let's break this. I'm going to break this. And this is going to be already assignment 2. All right. So this is first assignment. Let me start taking a look at the second assignment. So for that, what I'm going to do is that I'm going to go to my terminal and I'm going to create a branch for assignment 2, right? Because we're going to be taking a look at that. Let's say git checkout -b, and I'll create a branch A2. Okay. All right, so we're going to deliberately break this so that we can abandon React.js for a couple of weeks, right? We'll come back to this. Okay, so the way we're going to break this is as follows. I'm going to comment out this div, or I can just remove it. If I remove it, this index.js is not going to find the root, and it's not going to be able to inject anything, right? So if I go back to my index page, notice that there's nothing in there. See that? There's nothing in my index. In the bottom, my body is empty. There's nothing in there. And so what can I do? So in my index, right, I can now just use plain old HTML. Just plain old HTML, nothing else. Right? So what is HTML? So HTML is an XML language, right, which has a use case of being rendered in browsers, right? And it's made up of all sorts of these tags or XML elements, right? That's the official term. That's why browsers use these as, it calls them elements, right? Which is renders the DOM data structure, and it just it contains a whole bunch of tags or elements that tell the browser how to style certain things. Okay. And so let's style a few things. We're gonna say h1, and we can say welcome. And there it is, welcome. Now notice that the styling that's being used here, it's not using the default styling, so it's grabbing some CSS, some styling from some libraries, probably from some of these guys. My guess is that it must be in the head. Let's see what we have in the head. We have link, favicon, no, that's not it. Meta, blah, 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 no. Link, manifest, no. Okay, so it must be in the index. Let's go in the index. Okay, so it's not being able to do this, but it is still loading this index file, right? This index.css. Probably there's a whole bunch of style in there. So I'm going to comment that out too. Comment that out. Okay, now we're back to this is what the out of the box HTML renders as. Not very pretty, right? It's using the default font, right? The default styling that browsers use when they are not told how to render things. Okay, and so there's going to be the first assignment, just to give you a sense of what happens when you use just out of the box content, right? When you start coding. Okay. Was there something in the chat? No. Okay. So there it is. So welcome. Okay. So notice let's just introduce several of these tags. Right? The H1 tag is a heading tag. Right? It allows you to format content so that it looks like a heading. Notice that if you have content here, if you say, if you don't have this, right, it renders not like a heading. See that? So if I have here maybe a title, welcome, right, and then says, this is the CS 5610 assignment 2, right? Even though I add this additional tabs and new lines, when it renders, it ignores them, right? It ignores them completely, even though, right, I added this clearly as a title and clearly as this being a new paragraph, right? But that is not the way it works, right? If you have plain text, it just renders them from left to right, from top to bottom, and ignores any new lines or tabs. So you have to explicitly say how is it that you want things to be formatted, right? So here I want this to be a heading. So there it is. It renders it as a heading. And if you have a long paragraph, so let's grab ourselves a long paragraph. So there are examples of long paragraphs. Lorem ipsum is a very common paragraph used in the print industry, which you can copy. So let's copy that long paragraph. So let's just paste it next to here, and then just a few paragraphs. Okay. If you go back, you'll notice that the content is just strung together, ignoring completely, right? My new lines, my tabs, all my white spaces are completely ignored. Everything is strung together as one single thing, right? That's very annoying. But again, that's what HTML does, right? Until you specify exactly how you want things to format, it ignores you, right? So you have to, if you want this to be a paragraph, you have to explicitly say and surround it with tags that say that this is indeed a paragraph, right? So it adds, there it is. So it added some extra space between this paragraph and the next one. See that? Some space before and some space afterwards. So if I want this to be another paragraph, again, I need to surround it with a paragraph tag, close it. There it is. There it is, another paragraph. And finally, this last paragraph. There it is. See that? Okay. All right. So also, you'll notice that as I make my window larger and smaller, notice what happens to the content. See that? It tends to take up the entire width of the screen, right? And then when it doesn't fit, notice that things start to wrap, right? Wrap to continue in the next line. See that? Right? It's kind of like flowing from left to right and then from top to bottom, right? So that behavior of flowing from left to right and then wrapping when there's not enough space, right? It's called inline, right? It's a rendering from left to right, adding spaces between the words, right? And then breaking at the word. Okay, so that's called inline rendering. Okay. Now notice that that between these two, there is some vertical spacing. See that? Right. So there is no vertical spacing between words, right? It's just from left to right, right? But the words don't appear in individual vertical locations, right? They appear horizontally next to each other until there's no more space. That's inline. But these two, right? This over here and that over here, right? There is a break. There is a vertical break between this paragraph and that other paragraph, right? That vertical spacing behavior is referred to as block, right? Block rendering, right? It's rendering these two things as blocks. And blocks, what they do is that they take up the entire width of the screen, right? The entire width of the screen, and then push anything that continues. It pushes it down further, right? And it breaks vertically, right? It adds vertical spacing, right? So inline does not add vertical spacing, but block adds vertical spacing. Yes, and there are some elements, some tags that add vertical spacing and some tags that don't add vertical spacing, right? So H1 and P are paragraphs, so headers and paragraphs add vertical spacing. Notice at the head, this head, you know, if before it wasn't inside a head, so it was all, you know, it was all inline, right? But because I added inside of a heading, and because I added this in the paragraph, it added vertical spacing. So heads, paragraphs add vertical spacing. Let's take a look at a couple examples of things that don't add vertical spacing, right? So for instance, here, right, if I want to assignment, okay, if I want to highlight this, I could say put this inside of a bold B. See that? So I wrapped it inside some tags, but this particular tag does not add vertical spacing, right? See that? It changed it. See that? It changed it to bold. Right? If I add here and I underline something, and I underline that, that's another example of something that does not add vertical spacing. Even if I deliberately add vertical spacing here like that, right? The vertical spacing will be ignored. See that? Everything is in line unless you explicitly add a vertical spacing block element. Okay. Like for instance, I can add vertical spacing if I surround this as a paragraph. See that? There it is. See that constructor is adding vertical spacing all by itself, right? It added spacing above and below, right? And it wrapped the whole thing below it. Yeah. But that's not what the U and the B's do, right? So elements and tags that add vertical spacing are referred to as block elements, and elements that don't add vertical spacing that just flow from left to right are referred to as inline elements. Make sense? Okay. You know, regardless what you actually use for vertical, you know, new lines and whatnot, right, in your text editor. So other things that are important are that if you so in the element tab, you'll notice that there is a few things here. You'll notice that the first this part here shows all the elements and all the nodes, right, and all the branches in the DOM, right, in the DOM. This is the DOM. But then down below here, right, is styles. So these styles, right, tell us how are these things being rendered, how they look like, what colors, right, what spacing do they have, right? Are they underlined? Are they bold? Right? What size font are we using? Right? So for instance, if I select this welcome and I click over it and I inspect it, I notice that it highlights it on the elements tab. See that? But it also below it, it also highlights and shows me some attributes about the H1. It says that the H1 is a block element. See that? Right? That the font size is twice as big as all the other elements. So that's why it's bigger. So this is twice as big as all the other elements. Right? It also says that there are margins. So margins is spacing, right? Spacing between elements, right? For instance, the space between, say, this word and that word. See that there's a white space between it. So that is configurable, right? the spacing between this line, this line and that line, right? How much space do you want? That's also configurable. Notice that this welcome has some spacing between above and below. See that? And that's being configured by this margin. Okay, it says that it's 0.67%. So 67% of the normal spacing, whatever that is, right? Above and below. Okay, right? And notice that it draws a box around it, right? That if you hover, notice that it highlights the welcome, right? So if I click on welcome, see that it highlights this orange thing above and below, and then the blue. See that? So blue and orange above and below. See that? So this blue and orange, okay, refers to these orange, right, and this blue, in this box. See this box here? This box specifies everything that we know about how far the content is from everyone else, okay, or within itself, okay. And this configuration here is referred to as the box model. The box model specifies margin, the border, the padding, and the size. Okay, so margin is referred to as the spacing between me and everybody else. It says that above me, I have 21 pixels, 21.44 pixels above me, and 21.44 pixels below me, right? That's actually a calculated value from this 0.67 EM. So it's calculated in pixel size, right? I have no border. That's why if I highlight it, notice that it doesn't highlight anything here. I have no padding, no zero padding, and I am 569 pixels wide and 36.952 pixels high. Okay. All right. Everybody good? All right. So this here, it specifies how things look, whereas this specifies what things need to be rendered. Right. What things need to be rendered. The general styling, right? The logical styling of this. This is a heading, and that this is a paragraph. How headings are rendered or how paragraphs are rendered are configured using this other language. These are two different languages. There's HTML above here, and down below here is CSS, cascading style sheets. Okay, so HTML specifies the structure, right, and the abstract logical structure of the document, right, that specifying the intention of each element of each piece of content, that this should be a heading, and that generally headings should be bigger than the rest of the content, right? And that there might be multiple heading sizes, right? H1, H2, H3, H4, right? Presumably each one is smaller than the previous one, right? But these are all logical relationships between the different contents, yes? But the specific of how things should render are specified using a different language, the CSS language. The CSS language works as follows. It references things in the DOM, right? It says, hey, I know the DOM elements, right, have certain names, certain attributes. I can reference them. I can say, hey, all H1s, right, in the DOM, I want to apply these styling transformations, right? I want the font, right? I want to set the background color or whatever, right? I can so this, notice that it says that this says who is setting this? Who is setting this style? This style is being set by the user agent style sheet. That means that this is being set by the browser. The default browser is setting all this default look and feel. That's why you see that it's italic. It's italic, meaning this cannot be overwritten, right? This is what the browser says things should look like. You can't override the browser style sheet, but you can override and specify your own style sheets. that can take precedence over the default browser styling. So for instance, you could say that this particular element, right, in addition to all the styling that the browser says, I can specify and override certain things. I can say that the font size, actually, I don't want it to be 2M. I want to be 4M. I want to be twice as big as the default, right? So that's overriding what the browser says. Notice that my tool here, it says that this rule here, this transformation here, no longer applies. Notice that it scratches it, says nope, ignore this. This content is no longer true because I have overwritten it. Okay, and I can specify other things. I can say that the background color, the background background color, I can say that it should be red. Okay, and notice that indeed it changes the color of the background to red. Or I can say that the color, which specifies the foreground color, I can say that I want it to be yellow, right? And there it is. Yeah. Also, these margins, right? They might be too big. These are 42, right? Margins. I can turn that off. I can say that the margin below, all the margins, I can set them to 0. So now there's absolutely no margins whatsoever, right? All around. Or I can only specify a specific margin. I can specify only the margins above me at the top, right, to be 50 pixels. And I can make it bigger and bigger and bigger, right? Or below or left, you can say margin on the left, right, is 10 pixels. So I can move it to the left, right? Or I can specify an inner space, right? So we've been playing around with the margins over here. Okay, that this is how far we are from other things, right? Or I can specify an inner space of how far I am from my borders, right? From my outer border. So I can say that the padding, so padding specifies the inner space, within my borders. So I can say I want to be 10 pixels away from my borders. So there it is. See that? I'm away from my inner border, and I can make this bigger. So this is the inner space, right? Or I can specify the border itself. So I can say that the border, right, I should want to have maybe 10 pixel border. I want it to be blue, and I want it to be solid, right? And specify that is my my border. I can make my border bigger, right? I can specify different different styles of lines, right? There's several. I can say that I want it dotted, right? Or that I want it dashed. Oops, not that one. Yeah, dashed. Okay. Or I can specify individual borders. For instance, I might say that the border on the bottom, I actually don't want any borders. I can say none. I don't want any borders at the bottom. Or that the border at the top, okay, and I can specify individual items like the color. I might want it to be green, right? So I can change only the border at the top, right? Or that the border on the right, right? I can change the size or width, right? I want it to be instead of 39 pixels, I want it to be even thicker, right? I can make the border on the right only even thicker. Okay, so I can play lots with this, right? I can move things around. I can say that the position is a absolute, so that I can remove it from the normal flow of the content, so that I can then specify exactly where I want it, right? So I can from the left, I can say that I wanted to move it 10 pixels from the left, right? And then from the top, I wanted to move it maybe 100 pixels from the top, right? And then I can place it anywhere I want. And now I can do this either manually and specify categorically where I things and declare where things are statically, or I can use JavaScript. JavaScript can grab all this content and do this dynamically, right? And maybe do animations, and things can now, animate and squish and grow and shrink and change the colors into rainbows, right? Using JavaScript dynamically, I can do all sorts of interesting things. I can make games and things that bounce around, right? And make some interesting stuff, right? And that's where we're going, right? On how to do this statically. For the next couple of weeks, we will first learn all the ins and outs of HTML and CSS. We'll learn that it's actually very hard to make things look pretty with just plain old CSS. And so we will quickly abandon that and start and introduce a nice library called Bootstrap, which will make it very easy to make things look professional and polished, and also be responsive, so that it can be nice on a phone, on a tablet, or on a desktop. So it's really, really nice. Okay. All right. I think I'm gonna leave it here. Any questions?
So those modification you did is only on the browser, correct? Because we
Yes,
didn't
absolutely. If I refresh, all that is gone.
Oh, okay. Yeah, thank you.
So for instance, here's Canvas, right? We can modify Canvas. You can say, let's look at the module. You can see the HTML that was used to render Canvas, right? And for instance, if you don't like this line item, you can remove it. It's gone. See that? Look at that.
That's
Right?
interesting.
Or the entire div that runs to the left-hand side, all gone, right?
Oh.
Or change the content here, right? Which is, so you're manipulating the DOM, right? We're doing it manually, but we will learn how to do this dynamically with JavaScript. So you can change the content and see that right there. See that? Or you can programmatically do this, right? Which this is presumably some JavaScript iterating over some data structure that is dynamically rendering this, right? And depending on whether it's published or not, right? It's highlighting these buttons, right? So what we're going to learn, right, is how to build these things, right? How to use JavaScript, HTML, CSS, right, to dynamically build user interfaces, right, that based on some rules, based on data that is stored on the servers, data that is stored on databases, right, and how you can make respond to user interaction of adding new modules, deleting content, blah blah blah, right, of removing things and drop downs and whatnot. So that's the intent of the course, right? How to learn how to build these things, create these applications. Okay. Obviously, if I refresh, everything goes back. Okay. All right. Excellent. Anything else? So tomorrow morning at 8 a.m., I will be holding office hours for the undergrads. But if you have any questions and you can certainly are welcome. I will have to obviously give the undergrads priority, but I don't expect many people coming to tomorrow's office hours. So if you want to chat, you're welcome to come. All right, excellent. Thank you.
Thank you,
Good night.
Professor.
Thank you.
Good night, everybody.
Thank you.
Bye.
Yeah.